Yes, scholars, once again, this is TB Talks Education. Let us proceed with biology. Today, we are going to look at chromosome mutations that arise due to change in number of chromosomes. What are those changes that arise due to change in number of chromosomes? So now, of course, here we have two major forms of chromosome mutations that arise due to change in number of chromosomes. One of them is called aneuploidy, and then the second one is called polyploidy, also called euploidy. So we have two forms here. Two forms arise. Two forms. One is called aneuploidy. Aneuploidy. Then two is called euploidy. Euploidy, also called polyploidy. Polyploidy. So those are the two major forms of chromosome mutation that arise due to change in number. So now, let us discuss what we call aneuploidy. 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 So now, this is a condition whereby the total number of cells produced, of course, bears where half of the total number of chromosomes produced has an extra chromosome, and the other half has less than, actually is deficient by one chromosome. So here, half of the total number of cells produced has got an extra chromosome, and the other half is deficient by one chromosome. In other words, the other half has lost a chromosome. So now, that is what we call aneuploidy. So with aneuploidy, what happens is that some cells will just gain one chromosome, and some of them will gain, some of them will lose one chromosome. So that form of chromosomal mutation is called aneuploidy. So I can record that is a condition whereby half of the total number, half of the total number of chromosomes, total number of cells, whereby half of the total number of cells has an extra total number of cells produced, you can say, whereby total number of cells produced has an extra chromosome, that is 2n plus 1 or 2n minus 1. And the other half, is deficient. The other half is deficient by one chromosome. by one chromosome, or has lost one chromosome. Has lost one chromosome. Has lost one chromosome. That is 2n minus 1 to n minus 1, or n minus 1. So that is what we call aneuploidy, a condition whereby half of the total number of cells produced has an extra chromosome, that is 2n plus 1. Of course, that is for cells which are diploid, and then, or 2n minus, or shall I say 2n plus 1, or n minus 1. So this is a diploid cell which has gained one chromosome, and then the condition becomes 2n plus 1, or n minus 1. That is now a haploid cell, which it will be plus a haploid cell which has gained a chromosome. So that is n plus 1, and the other half is deficient by one chromosome, or has lost one chromosome, that is 2n minus 1, or n minus 1. So that is what we call aneuploidy. It is just simply gaining of a chromosome by a cell, or losing a chromosome by a cell. So that is what we call aneuploidy. And of course here, some cells are diploid, and thus if they gain, the condition becomes 2n plus 1. And if they are haploid, if a cell is haploid, the condition now becomes n for haploid plus 1. And then, if a haploid cell has lost a chromosome, then the condition becomes 2n minus 1. And if the cell is haploid, then the condition becomes n minus 1. Now, aneuploidy is caused by what we call non-disjunction during anaphase. So we can say that aneuploidy is caused. Aneuploidy is due to non-disjunction. Is due to non-disjunction that occurs during anaphase. That occurs during anaphase. So that is what brings about aneuploidy. So now here the question will be, what is meant by non-disjunction? Okay? Now, non-disjunction is a condition whereby the gametic cells that have been produced have extra chromosome or chromosomes, or have lost a chromosome as a result of a pair of chromosomes, or pairs of chromosomes failing to separate, of course, during the anaphase. So that is what we call non-disjunction. So I can write that non-disjunction is a condition whereby whereby gametes, whereby gametic cells, gametic cells, whereby gametic cells possess, whereby gametic cells possess extra chromosomes, extra chromosomes. I'm putting S in brackets because it can be one chromosome or there can be more. Possess extra chromosomes, possess extra chromosomes, or have lost, or have lost, whereby we say it's a condition whereby gametic cells possess extra chromosomes, or possess extra chromosomes, or have lost the chromosomes, or have lost the chromosomes, condition whereby gametic cells possess extra chromosomes or have lost the chromosomes, due to failure, of a pair of chromosomes, due to failure of a pair of chromosomes, or pairs of chromosomes, or pairs of chromosomes. So we are moving on. That non-disjunction is a condition whereby gametic cells possess extra chromosome, or they can be many chromosomes, or have lost the chromosomes due to failure of a pair of chromosome or pairs of chromosomes to separate during anaphase. So that is what we call non-disjunction. Okay? That is what we call non-disjunction as written on the board. Condition whereby gametic cells possess extra chromosomes or have lost chromosomes due to failure of a pair of chromosome or pairs of chromosomes to separate during anaphase. So that is what we call non-disjunction. So now here, what happens is that if non-disjunction occurs during meiosis. Okay? If non-disjunction occurs during meiosis, this results into cells with extra chromosomes, or few chromosomes few, we say extra chromosomes or few chromosomes. Few chromosomes. So now, what happens is that if these cells now fuse with normal haploid gametes, so what shall we form? We shall form zygotes with many chromosomes than the normal number of chromosomes. So if these cells or gametes fuse with the normal haploid gametes, zygotes with etc or less with etc or less the number of chromosomes, less the normal number. Zygotes with etc or less the normal number of chromosomes are formed. So now such a condition is called